Now, let us see this integration by polynomial substitution. Okay, so it is integral 0 to pi by 9. Okay, 6 sine 3 theta d theta. Now, let us take u as 3 theta. So du will be 3 d theta, and let us substitute it. And also, if you look at the limits as theta is 0, uh, u will be 0. Okay, and when theta is pi by 9, so it is u is pi by 3. Okay, now even the limits has changed. Now this will be u, which is 0 to pi by 3, right? 0 to pi by 3, and this is 6 sine u, and this will be du by 3. Okay, now this will be integral 0 to pi by 3, and this is 2 sine u du. Okay, so which is 2 times minus cos u 0 to pi by 3. Okay, so this will be 2 into 1 by 2 minus 3. Cos pi by 3 is 1 by 2, and cos 0 is 1. So which will give the result as 1. Now let us see this in problem by substitution method. So let us take u as t square. So 2u will be 2t into dt, or into du. Okay, we can write du will be, sorry, hold on. So du will be 2t into dt, right? So when t is equal to 0, u will be 0. Okay, when t is infinity, u also will be infinity. So let us substitute it 0 to infinity. So this is t dt by 2, and this is du by uh, 2, and this is e to the power of minus u. Okay, so this is 1 by 2. This will be minus of e to the power of minus u, 0 to infinity. This e to the power of minus infinity will be 0. Okay, so this is minus, if you take minus outside. Okay, uh, this will be 0 minus e to the power of 0 will be 1. Okay, so this will be 1 by 2. Now we'll solve this problem here. Now this is with respect to theta. So let us consider u as theta square. Okay, so du will be 2 theta d theta. Okay, now when theta is 0, okay, uh, your u will be 0. Okay, when theta is sorry, this is root pi by 2. Okay, root pi by 2. Okay, theta is root pi by 2. Okay, uh, your u will be uh, pi by 4. Okay, so your limits has changed 0 to pi by 4. This is u, and cos u into du by 2. Okay, so this is 1 by 2. Cos u is sin u. Okay, 0 to pi by 4. Okay, sin by pi by 4 uh, will be root 2 by 2. Okay, 2 by 2. Okay, minus 0 sin 0. So which is root 2 by 4. Okay. Let us solve this problem. Uh, Now we'll consider here u as root theta. Okay, so du will be half theta to the power of minus half d theta. Okay, so which is 1 by 2 root theta d theta. Okay, so let us substitute it, and then the limits again when u is 0. Sorry, here consider t as 0, theta as 0, u is 0, right? When theta as pi square by 4, so uh, u will be root of theta, which is pi by 2. Okay, so this is 0 to pi by 2. Okay, now this is sine u, and sine u into du. Now this is 2 times du. Okay, so 2 integration of sine u is minus cos u 0 to pi by 2. Okay, so minus 2 cos pi by 2 is 0. This is minus 1, so which is 2. Okay, now we shall solve this problem. So square root of 1 minus root x. Let us see what we can consider as what we can substitute here. So we can substitute u as 1 minus root x. Okay, so du will be uh, this is this is uh, this is minus half x to the power of minus half dx. Okay, or this is minus 1 by 2 root x dx. Okay, so we'll substitute it here. So here we don't have any limits to change. Okay, so this is a root into u into, now when you're substituting it, this will be, this is okay, so root u into minus 2 root x dx du. Okay, which is dx. Okay, or we can write this as minus 2 integral root u root x dx. So from here you can consider root x as 1 minus u. Let us substitute it. Okay. So this becomes minus 2 integral root u into 1 minus u into du. Okay. So this whole thing becomes root u minus u power 3 by 2 into du. Okay. Let us integrate this. So this will be minus 2 integral u to the power of half becomes u to the power of 3 by 2 and 2 by 3. So this is 2 by 3 u to the power of 3 by 2 and minus this will be u to the power of 5 by 2 and 2 by 5. Okay, plus c. So let us substitute it. This is minus 4 by 3 and 1 minus root x to the power of uh, 3 by 2. Okay. And this is plus 4 by 5, 1 minus root x to the power of 5 by 2 plus c. So this is the answer right here. Okay. Now let us see this. Now this is another part, the problems which you are looking here. So integration by trigonometric substitutions. So if you can see here, sine theta will be helpful for us to substitute as u. So u will be sine theta, so that I can we can, when you differentiate this with respect to theta, so that will be cos theta and d theta. Okay. So let us substitute it. So this will be u cube into du, which is u power 4 by 4 plus c, which is sine power 4 theta by 4 plus c. Okay. Let us solve this problem. Integrate 0 to 3 dx by square root of x square plus 9. Now, we rewrite x square plus 9 in the form of x square plus a square, right? So a square is 9, so a will be 3. So now we should make the substitutions here as x as a tan theta, okay, which is x is a as 3, right? So x is equal to 3 tan theta. So dx will be um, a, which is 3 secant square theta d theta. Okay. So now your theta, here if you consider this, theta will be uh, considering this, theta will be tan inverse x by 3. Okay. Now, as we have changed x as with respect to theta, so when x is 0, theta will be, when you substitute it, it will be 0. When x is 3, tan inverse 1, which is pi by 4. So theta is pi by 4. So your limits is 0 to pi by 4. So this is dx is 3 secant square theta d theta divided by This is square root of x square, which is 3 square tan square theta plus 3 square. Okay. Now, tan square, uh, 1 plus tan square theta is secant square theta. So this will be 0 to pi by 4, 3 secant square theta d theta divided by this is 3 secant theta. Okay. So which is 0 to pi by 4 secant theta d theta, right? So which is equal to ln secant theta plus tan theta. Okay. So which is 0 to pi by 4. Okay. So when you substitute it, so this will be ln of secant theta pi by 4, which is root 2, and tan pi by 4, which is 1, okay, minus ln secant 0 is 1, and tan 0 is 0. Okay, so finally you get a ln of root 2 plus 1. Okay.